So, my name is Vassilis Rizopoulos. I am principal consultant for Zulke in Germany. And up until July last year, I was leading the backend team for the NHS COVID-19 app. In the meantime, I have moved on to other projects and other pastures. And what I mainly do is set up teams to deal with automation. And for that purpose, I managed to put a few things together and create what we're going to see here today, a set of conventions and tools I call Gaudi. Now, does anybody actually know who Gaudi is and what the name refers to?
Architect.
Yes, Gaudi is well, was a very famous architect. He is his name is inextricably connected with the city of Barcelona, and his style and the way he produced his works had one specific characteristic, and that is he actually never produced plans. He always created models. He would build in small, and then sit in front of the construction yard and direct everybody on how to do things and how to fit it. And it kind of, well, when I initially did this work, I used to live in Barcelona, so part of the name is also connected with my own personal history. But the idea behind this system is that it gives us a very unified, very organic way of driving every task in the software development of a project. Now, I call this a build system, and I have to say I have great difficulty in separating what we're gonna talk about today. I'm gonna rush through things that I consider the most important parts and the reason for existence for Gaudi, just to show you how the little tool works, and hopefully in the flow of things, we're going to touch on the actual important aspects. Now, for anybody wanting to follow along and see this, most of this presentation, so there are no slides. The slides are all markdown configuration, and they are available in GitHub. I'm going to post the link to the repository in the chat I just did. And you can click through this and copy paste with me if you want to do the hands-on stuff. So let's start from the very beginning. Now, the term build system is generally a bit overloaded. For people of a certain age, when you say build tool and build system, the first thing that comes to mind is make. And every technology stack and language has invented its own by this time. Now, Gaudi itself is based on Rake, which stands for Ruby Make, and leverages a lot of the capabilities that the Ruby language gives it. But that is beside the point. What it is meant to be is a set of conventions, an idea on structure, and a consistent command line interface so that we can drive every task in software development with the express purpose of automating, maximum degree of automation. So what we're trying to achieve with what we're going to see is these 5 rules, 5 aspirations, let's just call them. This is taken from the Gaudi website repository in Git, where there is a little bit more text on the thinking behind the tool and the way it's put together. So what we want to do is to have just the repository. Always keep in mind that our goal is maximum degree of automation, and this is something that is very, very helpful in today's fast-paced, cloud-based environments. Just a repository, meaning theoretically, in the best of conditions, I will be able, with a copy of my repository, to recreate my infrastructure and my project from scratch. That's the idea. Okay, along the way, we do a lot of compromises and stuff, but the idea would be to have everything coded in such a way that with a copy of the repository, I can, if the infrastructure is destroyed, I can recreate. We require one source of truth. When something changes, we should only change it in one place, and when we need to figure out something, we only need to look in one place. It would be good to have a logical rule on how to get to that place. We are all experts. This is the basis of automation. I need to be able to do everything in the project, no matter my role in the team, without caring about the excruciating technical details. Out of source builds, this is a very build system specific feature, is don't mix whatever is under version control with whatever is created by the various processes that we do in the build system, and breadcrumbs everywhere. Have to have a trail of everything, every command, every task, and everything generated in such a way as to be able at any point to say, to recreate what happened in the various processes. In logic theory, this is called the Ariadne's thread as well. So how do we go about achieving these goals? How Gaudi goes about achieving these goals? Well, there are 4 things that the core of Gaudi offers. An organization for convention for organizing code, a specific structure on where to put the code and how it should look. This is one thing that we generally, in my experience, when I come into contact with teams that want to introduce a high degree of automation into the systems, this is something that is missed. A build system, the collection of scripts that drive that automation, is software, is code. And code needs guidelines, styling guide, and a structure. So a build system is a software project in and of itself. So it benefits a lot from having a structure and conventions on how it should be. And given that our goal is maximum degree of automation, the result is that we get a lot of code in this, which is not production code, which the supporting structure, all the scripts and all the code to drive this automation rivals in complexity, if not in size, the actual code of the product we are building itself. Second part. So these are the 4 things we are going to see today. So we're going to see a single aspect of each of these points. So how code is organized in order to be able to manage the build system, the configuration system that Gaudi implements, so that we have a single point where we go and see how things are set up. and wire together. A documentation concept, because one of the things that crucial to build system in my experience, and this is something that we had a lot in the NHS project, is the there is a lot of expertise in the code that automates something. This needs to be communicated. This needs to be documented. This needs to be communicated. And it's good to have one consistent way of doing these things and making it easy to do it. So there is a suggestion on how to do this as well. And a command line calling convention and a way of interfacing with the operating system Gaudi runs on. One is because there are always parts, things like secrets and certificates, and that should not be part of the repository. So we do not, we avoid versioning them. We avoid persisting them, but we have to have some way of passing them into the system, especially passwords and credentials and all of that. And the other part is that we want a consistent user interface, because developers are users of this. The developers are the users of the system. And what we are aiming for is a very consistent developer experience. And we will see, or hopefully I will be able to show how this benefits a team when it's done correctly. So much for the talk and the introductory. I'm kind of rushing through this because I'm not sure I have paced the content right. Please feel free to interrupt me at any point from now on. And this is where we start with some concrete things. Now, you can actually follow by simply following the instructions on the slides. That's why I posted the link to the repository as well. And all of the tooling that we need is encapsulated in one Docker container, which you can pull down from Docker Hub, and just create an empty directory on your computers anyway, and start the Docker container like this. And this is how it starts. Now, this Docker container basically mounts the directory in which you run the command in inside the container, and at this directory workspace. And for this, and through this we will be able to edit on the outside and do all the work within the container. Now, this is crucial for the pace at which I'm going to follow. Is anybody following with the container on the hands-on?
I'm trying to follow you. Unfortunately, I can't see the link that you're showing us on the screen, so I can't actually click it. That Docker pull
This
stuff.
link on the chat?
Yeah, the preview example. Where do I find that?
The link. So this is the chat. Oops. I posted in the I posted it in the Zoom chat. The last message in the Zoom chat should be the
next to the orange tick.
Sorry?
That takes me to the repository.
Yeah. If you click from the README down, this is exactly what I am showing is the contents of the repository, just Markdown preview. So this is the repository in here. So I'm just all the whole slides of the workshop are available in that repository, and we're just going through them one by one.
Yeah,
so you can copy paste from
there.
there.
Don't see the very first link that I need.
You go from here. Oops, sorry. The very big. So dive straight. The very beginning. This is the start. That's the approach. And now this is the setup for the.
I can see that one. Okay.
Okay, so okay, I have started the now. This whole delay should actually also help whoever wants to download the pre-built container. It takes a while. This container is built exactly the same way that we used in the project, and it actually uses your code for setting up the shell, the user rights. Start. So I'm just gonna pull in exactly this code because I don't like typing very much, and I am cloning the example, the repository for the Gaudi example within the container, and now this should be here available, and we also have it here to see. So I can solve that. Now we have. How do we start with Gaudi in general? I'm trying to make it as easy as possible. So basically, we'll create a directory. Okay. An empty directory, which is here, it's empty. And what we're going to do is we're going to use what is called a Ruby gem. So a Ruby gem is a gem is a Ruby package. It can be installed by gem install Gaudi. This is the thing that I didn't mention. The whole system leverages a lot of the Ruby ecosystem, and the code included is Ruby language code. I am going to skip through the simple usage of. So I'm not going to go into details on what Ruby is and how Ruby libraries are put together and how they are connected, unless it pertains to writing code for the build system, simply out of time restraint. But installing a Ruby gem is analogous to installing a library in any other language ecosystem. So pip install Python for Python, npm install for JavaScript, etc. Now, the gem itself has only a single function. It doesn't have a single function. It actually provides integration help. So, and the main function of the gem is to provide a scaffolding for a project that uses Gaudi, and that's what that command does there. And once this is done, and what it does is it goes to the open source repository, pulls down the core of the system, and puts it under tools build. That's all it does. And now, having done that, we have a working Gaudi installation. Now, Gaudi uses the build tool provided by Ruby in the standard library, which is called Rake. And the reason Gaudi is based on Ruby is part of the reason, one of the biggest pull for it is exactly this tool, Rake, and the DSL, the domain specific language it offers for describing tasks and their dependencies. The combination of the simple DSL, the Ruby language, and the help built on top arguably makes it easier to reason about the code. Hopefully, we will see that in the next few steps. Now, Rake -T gives us a list of the available tasks for the system. So out of the box, and first of all, is it visible or should I increase the font?
A little bit bigger would be nice.
That way? Is that better? Okay. Now we can cross this.
So much reflection from the lights.
So, out of the box, the tasks, we get a bit of a cleanup task and a couple of tasks to generate documentation. More on these later. So, and no actual usage for us at the moment. What we have is a structure already laid in with the documentation. As you can see, there's a little bit of markdown already put in the doc directory and the tools directory that contains the build system code. Now, let's add a very simple build task. Okay, I will copy and paste these two things. And so, part number 1 of Gaudi, define a set of conventions for organizing and managing code that belongs to the build system and automates things in our software development procedure. We organize code is organized in what are called Gaudi modules. Forgive me, but I chose the word module like almost a decade ago. I didn't know enough, and then the term module is too overloaded. That's why I always say Gaudi modules, and it becomes very verbose when trying to explain. But yeah, it is what it is now. And once we basically what are Gaudi modules? Gaudi modules are a subdirectory in the tools build lib. Okay, that contains that the name of the subdirectory is the name of the module, and then underneath it there is a helpers directory and a tasks directory. Rake tasks, build system tasks will go into the tasks subdirectory, and code organized for reusability, functions, methods, objects, classes, and all of that stuff will land in the helpers directory. And in order to activate the system and make it and have Gaudi recognize the code that is included here that we will put there, we go into the main configuration file, which is in tools build system.csg, and then set up, tell it that look for a module called workshop. And this now from this point onward, now that we have activated it, if I do rake minus, I mean, I haven't added anything yet, but this is still working. Yeah, thankfully. But what happens is that any code that is included here will be any code that is created in the helpers will be automatically required, is the term in Ruby, included, imported, and be available for code in tasks to use. And that's why we set it up like this. Now, let's get something building. Make things fast. I will create a directory to put sources in, and in order to not get too bogged down, I am copying a prepared set of sources from the Gaudi example repository. What did we do? And now I will that pre-prepared example is a simplified version. This is it, a simplified version of the Docker container image source code that I'm using here to conduct the workshop. It's a simplified version so that it's a bit smaller and it builds faster, not much, not for any other reason. I could have done it completely the same. I actually initially I did use exactly the same sources, and then I realized it takes too long. So it's basically a Docker file with some magic to make it work seamlessly on Mac OS and Windows. By the way, this magic is Emo's code.
Thanks, Imo.
It's actually pretty cool. Keep using it all the time. Copy paste. Now let's go and create a file called build.rb. Since we're having a build task, so we're going to build it. Let's call it build.rb. So the file to contain our build tasks, and copy paste the code. Copy paste the code in there. Now, very fast run through the Rake domain-specific languages. Domain-specific language. What Rake does is these are basically all of the terms in the DSL. Tasks are each task can have a description, and tasks are organized in namespaces. And this is the simplest way of doing something in Rake. So what I did is put the command line that I want executed. This means execute a shell with this command line. The semantics of the sh call is that it will throw an exception if the command line returns with an exit code other than 0. And what I will now have, if I look up the list of tasks that are available, is in my list of tasks a task that says here, build the development environment. Okay, and we can do this. So this is the call, and this is the invocation. Let's call it. As you can see, it will download quite a few things and build the development environment. Now, this is, if we want to be really pedantic, 90% of the work of a build system. Put together strings that represent command lines, execute those command lines, and have a way to determine if they are successful or not. And that's all there is to it. So how do we go about, and the experience shows that if you put it like this way, people tend to trivialize the problem. It's a few scripts. It's a bit of it's not it's trivial. It's easy. It's not something that we need to spend a lot of time with. Experience shows that in any project of significant size, which for me is any project that involves a team of 5 ± 2 and runs longer than a couple of months. These collection of helper scripts and shell scripts and automation and all of that very, very quickly goes out of hand, gets out of hand. And so what we have introduced here is now a single place with a known structure and a way to group these different tasks together. The work for the build engineer becomes to to actually name the tasks properly. So we all know that naming is one of the two hardest problems in computer engineering today. The second being cache invalidation, and the third being off-by-one errors. So now that I've wasted enough time so that Docker can do its thing and build significantly, I will go to the next slide, which is this simple task implementation also showcases one more thing, and that is how the configuration, this central system configuration that Gaudi reads is used in the code. Now, by convention and by default, the file is tools build system.cfg. You can follow the links to see what exactly the configuration format is. Very simple. It's like a property format, so key equals value with a couple of extensions for convenience. And what we're going to do here, for brevity's sake, is use what comes out of the box. And what comes out of the box are two attributes, a base and out, and what happens is that this configuration file gets read into an object. Now, for anybody knowing Ruby, they will realize that this object is global. So any variable in Ruby starting with $, is a global variable. So this Gaudi gets a little bit dirty. It reads the configuration file and puts it in a global variable, which is then available throughout the code that we will write. And does a little bit of extra work to ensure that paths are interpreted correctly. So if you notice in the system configuration, the paths are set as relative values. One of the important things when actually logging things and giving errors out is to convert these values in absolute paths, because there's a lot of errors that come in when we're trying to interpret how many dots there are in a path. And so the code behind Gaudi will do a lot of work to make sure that these values are parsed correctly, and they are then exposed as attributes in this configuration object, a context configuration object. And the code of the task here shows exactly how this is supposed to work. Now, the dot base attribute is the root of the workspace, and the out attribute points to a directory that is going to be used to put any artifacts of the build process in. Remember back to the out of source builds goal we're trying to achieve. So keep the version code separated from the byproducts of the processes. So as we can see here, we have now successfully built the Docker container. And I'm going to click the next one. So now the very simple shelling out for a single command line is fine for the beginning. In the list of goals, the last one is we actually want to be able to follow what happened, and Gaudi's goal is to provide maximum degree of automation, but also to be used as the staging point for automating the build processes in a CI/CD context, for example. And when that happens, a robot runs the process, executes the process, and we only need to look into what happened when something goes wrong. But when something goes wrong, we actually need quite a very consistent way of figuring out what happened and where it happened. This is what the breadcrumbs are. Now, again, I'm gonna be lazy and skip writing that code. But what I'm gonna do is I'm gonna copy a helper library. This is what I just did. Okay, we can look into this code in a little bit and rearrange the task we just wrote so that it uses that helper library. All that I did is add code that introduces this method. Okay, this is a code. Now there's a little bit of Ruby in it. In the Ruby language, reusable modules of we group methods into modules, and we can include modules in object-oriented parlance. This is called a mixin. So we're mixing in a module, a collection of methods into our task. That module is called execution. Okay, we build our command line, and then we run the command line and give it a little bit of metadata so that it logs nicely. Now, if I rerun my code now, exactly the same task, same execution, same invocation form, I will get. I didn't save. That's why I get logs. I get a much. I don't get the standard output of the command. What Gaudi does in this case is output the command line that is invoked, and tell me status and give me some data on execution time. This is what the code in execution.ip does. And what happened now, though, is that in the out directory, I have a subdirectory log with a timestamp breadcrumb, which is the contents of the output. So the output of the command. Now, given this helper library, so from now on, every time I call a command like this, I will get a log file persisted on disk. And then if I want to bind it to Azure DevOps or Jenkins or code build in AWS or any of the build automation systems, at the end of every pipeline, all I have to do is archive this directory and have a full log of whatever happened in my system. Consistency. Now, okay, like I said, we introduced this library of sorts, which is called execution. Let's go to helpers. Okay, we put it in the helpers directory. Oh, I talked about all of this. So we have a collection of methods organized as a module. This is features of the Ruby language. There is a set of style, a bit of a style guideline, which is documented in the Gaudi repository. The link is in that slide on how helper methods should look to keep a consistent look and feel of the code. And there is, and those are just a couple of rules on top of the default set of rules that the Ruby community enforces with the Rubocop and Rufo tools. Rufo is the Ruby formatter, Rubocop is a linting tool. The standard set of rules agreed by in the Ruby ecosystem apply, plus a couple of style guidelines that are documented in the repository. So we talked about this. So we saw the convention for the structure convention and how to organize the code, whether the configuration is, so where is the single source of truth for the build system. We also talked, we need to have a consistent way of documenting. Instead of reinventing the wheel again and again. What Gaudi does is offer out of the box. Gaudi offers, oops, excuse me, offers these two tasks. Basically, the doc Gaudi and the doc graph Gaudi task, and leverages the inline code documentation system that Ruby provides, which is called RDoc, and allows you to create the documentation. So if I do doc Gaudi now, the system is going to go parse all of this code in here, include any markdown files it finds in the doc subdirectory, and in the output will generate a documentation in HTML format, which includes a brief introduction on the build system. This comes with a scaffolding plus reference documentation for the code included in the system. Now, and if I click on execution, I can see the method we introduced just now. I can also do nice things like click and see the code, how it looks like. And okay, let me put this away. So we put the code in a place. We have a way to document it and refer to it. We introduced a bit of helper code to implement this idea of the breadcrumbs. And we have a task that builds our Docker container. So what comes next? So you have a Docker image container built. I would like to publish it to a registry. Okay. And now this is the part where we start talking about how to go about structuring a build system. And this is the point where we go away from the actual tool that we use here. It's an approach of building up a set. The calling convention of Rake and this structure of namespaces allows us to have a logical model on how to name tasks. Now, I can actually, I will actually go to the very beginning of the code of the slides, and this is the context here. Okay, and show you this pretty colorful little diagram, which basically identifies the parts of the software development process that fall under the auspices, that can be automated, that fall under the auspices of the build system. So we can generate code, we can build, unit test, link, call static analysis tasks, package, deploy, and test. Now, the blue test is meant to represent integration and system testing level testing, while the yellow one is the unit testing. This is quite a bit an old diagram. I tend to merge unit testing with build in the more recent years. Now, if we start putting things in these little boxes and labeling like that, we can actually reflect this in the structure of the tasks the build system implements. So we have namespaces like gen for generate, build for build, a lint for static analysis, unit for unit testing, test for testing, etc., etc. And this is what I'm doing now. We should be here. So I built the development environment container image. Now I'm going to publish the container image. The way we talk about what we're doing informs how we name the tasks. So I'm just gonna copy this again in there. And then I will. Oh, this copying up here is another bit of helper code that wraps a couple of the Docker commands in methods so that they can easily be used in the code. And then I'm going to go to the build system in our little corner and add a new file and namespace. This is how we go about building up the system. And I copy pasted the code in. Now, if once let's see, did it catch? No, it didn't because I didn't save. Very simple. So, Rake, now I have a task to publish the container we just built. What happens here in this task? The important part, the part I want to focus on because it's Gaudi relevant, are the lines 5 and 6, which is which is a way of so I want to publish in order to publish the task. So if I call it like this now, it will fail with an error message. That's the error message that I defined here. So what I'm doing here is I'm reading an environment variable which I use to pass in the parameter of the Docker registry so that the task can publish in the correct Docker registry. And then I'm checking that it exists, it's valid, whatever. I can do all my validation here and throw whatever errors. And this is what I did. And this is a very valid way of doing it. And it's actually Ruby, the way Ruby provides in order to communicate with the environment variable, to read and write environment variables. Excuse me.
Today, that there's another way of passing arguments into the program, which is to put square brackets after the Rake task name.
Rake offers two ways of parameterizing tasks. The choice of using environment variables to pass in parameters to the task is a convention. So the Rake DSL itself is a little bit more complex than the things that we use here, but this is also something we discussed several times with the teams. Build system code. So a build system is a software system. So it actually follows. When we write code for it, we should follow all the rules and style guides and regulations that we use for any production code. It is actually more important because the clients of the build system are, for me, I joke around and I say that a build engineer has the worst clients in the world, developers. They want things yesterday, performant, scaling. And flawless. While they're doing things, keeping a build system working is a race against people that want to produce more and more and more and more. So the more my experience, apart from using something like Gaudi, the structures, the conventions, setting up very conventions, my experience is that the code produced in the build sim needs to be naive, simple. It should not be clever. And then and one way of keeping the code simple is by consciously choosing one thing of all the options. So maximum flexibility and extensibility is is fine, but not in a build system. We sit down with the team, we decide how things are done, and we keep this. And most of the work becomes making this consistent. It also calling the code naive also means avoiding the more fancy tricks of the language. Ruby, for example, is a dynamic language with a lot of metaprogramming capabilities. It can do very, very fancy stuff, very clever stuff. Avoid that. Wow. Really, don't make it as the code in there needs to be as readable as possible. And the way I say this is that nobody actually cares for this. Nobody's gonna go wild, optimizing, golfing, making the performance of the build system. The build system is a secondary priority for most teams. And chances are that a lot of people are not gonna be versed in the language used, especially if you use Gaudi. It's also another point in this is that you introduce another ecosystem and another language whenever you introduce a tool like this. CMake, for example, is also extremely advanced and can do a lot of things, and it's basically a programming language in itself. Any of the JavaScript tools introduce JavaScript in the task. Okay, I don't want to go into the other build tools. Make is a language itself as limited as it is. The more limited the language used by the build tool, the more exotic the solutions for things like putting sticks together and stuff like that. I have found that the combination of Ruby, Rake, and this keep things simple and readable is a sweet spot, in my opinion, as always. Now, but what this is why I like the use of Ruby. Okay, I have an access to the operating system environment variables, and I have a way, and I can perform validation and do errors. Now, this is a very it's a pattern that occurs more very often. Being able to pass values via environment variables and have a place where these things are validated and can be documented is very useful. And that's why Gaudi includes a way of doing this simpler in the core of them. And this is called the environment. Now, the Gaudi repository actually documents in detail how these things are done. This is one of the places where we take advantage of Ruby's extensibility and open classes and dynamic nature of the language. Basically, what we're doing is we are we're gonna add a helper, which is called by convention, as always, environment.rb. Okay, and in this helper, we're going to copy paste this code. What this code basically does is it goes into this module, which exists. It's part of the Gaudi core classes and modules. And come and adds this method. Now, the only thing one needs to know is that this method, this is part of the reference for Gaudi Go, will look for an environment variable called the name of the parameter, and if it doesn't exist, throw an error. So I'm going to save this, and then I'm going to change those two lines in the code of the publish task with this code. So by adding methods in this particular module, what happens is those methods get added into the context object, the configuration object, and so I can actually call them and have access. Now, what have I achieved with this extra level of redirection? If I now run the documentation and go back to this code, reread it, I have environment options there, and oops, I didn't show up. Hello. I did something. What did I do? Ah. Okay, that should. Where's that? There it is. Oh, yeah, no, sorry. So if I document the method, okay, and I write my code, I should be able to have this here. I don't know why. So this is the helper. And I am now.
You might have to clear a cache.
Yeah, I might have to clear. Or this is. Let's check. So that's my output. Yeah. Please give me a second. Give me a second. I need to take care of a 13-year-old. So while I am, okay, what happens this?
You want to tell us about the SPA conference, mate?
No, it shows it's live.
Yeah. I was just wondering if you could get some of those software identity tags in, just routinely build versioning. Shouldn't be too hard.
Were you modifying the correct project, the workshop project, or the example?
Yeah, well, this is the workshop project here, and I ran the documentation here.
We've got project.
So basically, what I can do is I can just delete the documentation and
Eating your own tail.
redo it. But before that, I need to give the little kid a bit of time on the computer. I'm sorry, this is a bit of a distraction. Okay, I am back into. So, this is actually the Ruby terminology for having Gaudi configuration environment options, which is Gaudi configuration environment options. And we did this. And I'm running this, and hopefully I am actually reading exactly the same code. This is it. No. Okay. I can't figure out why it's not showing up, which it should. But and it this is embarrassing.
No, it's brilliant.
It's always the same.
If it had been perfect, we wouldn't have believed you.
Now, the whole the idea about this and why Indeed does this is to basically have all of these options in one place, because the environment variables basically build the interface between the build system and the operating system, and we want these in one place. So leveraging the documentation and putting this mechanism into place to provide access gives us a single place to look for all of these entries, a place to document them, and there's a way of doing validation.
The sweet spot for audit, very, very simple to audit. You don't have to dig too hard and you don't have to be a programmer. I can look for those key things I need to see in one place. Very simple to audit. Thank you for that.
And basically all it does here is, well, now the message now has changed because it's abstracted. It's a more generic thing. It's like you didn't put a value in the environment variable, but that's what mandatory does. Okay, so with a slight hiccup, we've put this. Now, once we do the thing, okay, there's one more thing to put in the whole Gaudi, because this is it. This is Gaudi. This is how it is. The work then is to keep adding those tasks and massaging the code in such a way that it is readable and manageable. The way we go about this usually is introduce the task. When the code within the task actually becomes useful, factor it out into a helper module, and then use it in multiple tasks. And it goes and it builds very, very organically and step by step when you start from the beginning. Now, one of the interesting parts one of the modules that I introduced, for example, that I just copied here in order to do not have to type the code, is like Docker integration. And it's, again, what I said in the beginning, very simple, put strings together to create command lines, and then have methods, and this is where it gets philosophical. What we do here is we codify the way we use the tools. We fix it in code. This is how the team uses this tool. And that's where Gaudi becomes the meta abstraction layer to start integrating all the different build tools and processes for all the different technologies that get involved into the software project. And this is where it starts getting interesting. In the case where we got more than one thing going, we have a Terraform thing, we have a Java build, we have a bit of CMake, we have .NET stuff. We put them all together in a cloud or a virtual machine or a configuration management tool like Chef and Puppet and Ansible, and we want all of these disparate things. We want a simple, consistent way of calling them, referencing them, and that's where the whole work gets into. Now, the next step after that is, once you've built a bit of code with all of these simple integrations and have established ways of using them, you start wanting to use them again in other parts. And this is where the gem comes back into play. So we said a Gaudi module is a directory with the name of the module and a helpers and a tasks subdirectory. This is a very nice, simple unit of reuse for code. You can get a bunch of tasks, you can get a bunch of helpers, and put them all together. And we do this a lot.
Okay.
Yeah.
If you had say a specific domain language, like a data language, say RStudio, something like R, if you wanted to orchestrate the data lakes going into something else, have you ever done anything like that? Presumably when you've got large seas of data, this is perfect for that.
Anything with an API or a CLI can be orchestrated.
Yeah, like the largest sample of code, of Gaudi code, is actually the NHS COVID-19 packet.
Really?
It's all of the complete, all of it, the deployment, the builds, the orchestration, the creation of new instances of environments, and all that. It's all of that, and it's in GitHub.
Could you get a bill of materials for, say, log4j vulnerabilities out of that orchestration, just by watching what was being run and logs?
I can't tell it now because I was, but the experience, my experience is that once these things are codified like this, it becomes very easy to teach it and very easy to find it, and then like instrument it where you want it. And we've done this multiple times.
So for you, it's a living workspace, but I can see that you use it as a universal room of requirements.
I did exactly this. It was my toolbox. It is my toolbox. I will put something in when I figure out how to use a tool or an ecosystem or a thingy, I will put that in tasks and integrations for myself. But what I found out leading the teams was that it became a very effective way of ensuring that people know how things are done. So teaching, disseminating what we agreed on how things are going to be, the different processes that we use. That was one. And the second effect was confidence.
Yeah.
Because it was like, what do you do? Deploy production.
There it is.
That was it. What do? You do deploy prod. You don't do anything. This is the thing. The build system does everything else, make sure that all the little fiddle things, and then now there is a lot of work to be done in the individual technology stacks that we chose in order to figure out how to put these things in code, how to make Terraform, convince AWS to do all the parameters correctly. But this is more the work of learning the individual technologies and having an expert figure how to do these things and put them into script.
So you'd have a table of owners. Your rake would be owned by your Ruby. Your make would be owned by your C expert. And then you can make a clear audit trail for who did what.
Well, the audit trail is the repository, the log, the Git logs. That's pull requests coming in. It allowed us to basically leverage the expertise of everybody in the team. Okay, and then at the end, everyone knew how the system was tied together, put together.
So everyone had their own little bit.
It's not that everybody did the thing. So everybody was drilling down and did the thing they could do best. Yeah. But this unified UI, so operating this rake-t is as simple as it is, and because it is actually rake-t, that gives you a list with the task and what the task does. Okay, and this meant that anyone with the proper credentials could do anything. So was an expert at anything. This is the thing. I am the expert of all things. I can do, anyone in our team can do production deployments if we give them the right to do that. And they will not break anything.
I think
that's the confidence.
To show about prerequisites, because those allow you to build sort of declarative map of what things have to happen in what order.
Let's do the other thing. Let's show the
graphs.
Okay, basically this is the graphics integration built into the core, which maps the tasks. Okay, we don't have a complex system at the moment, but we have only, these are all the tasks that are available in the system, plus the dependencies mapped to each other. Gaudi generates that out of the box. Now, if I try to do exactly this command in the NHS build system, the picture would not be readable. It's like it is too much in detail. But the the gradual build-up of these things, and what we do is it's also the Lego principle. You start by structuring the tasks in such a way that they build upon each other. So you build chains, and at the end, we can have one task that is a complete pipeline for build and deployment. And what this ends up, the benefit that we get out of this is the extra benefits, automating. So CI/CD is a byproduct. Because all we need to do is call the correct task in sequence in the CI/CD tool. So I can use any CI/CD tool I want. This is what enabled us, for example, to move from GitHub workflows to code build, AWS code build, without breaking sweat.
So you don't rely on Git, you just sit on it.
Yeah, basically.
Yeah. The CI/CD tool needs to give me, needs to be able to clone a repository, and the next thing I do is call a rake command.
So by design, you've created a system with no vendor lock-in to GitHub.
Or to AWS for that matter.
Whoa.
This also is very crucial. I mean, I am a consultant for Zulke. Zulke is a technology business that provides solutions for multiple clients. Avoiding vendor lock-in is the requirement for me most of the time. So yes, this is the way of having. I don't believe in avoiding vendor lock-in. I think that generally lock-in is unavoidable. If somebody is actually honest with themselves, there is no way you will not get locked in.
Is this, or was this, a hard sell to the NHS? Did you have problems?
Honest, they didn't get a choice. It was a very hard decision to introduce it. So so a bit of a timeline. We got the go to build the backend from the ground up, zero, completely, like on the 5th of May, with a feature freeze deadline on the 5th of August. The goal was to actually get the app out before schools start. And there was a team put together that needed to do this job in this time frame, and it was quite challenging. Very. We had to learn how to implement the backend, the requirements for the Google Apple API, like I said. So a lot of things, and very quickly, because we also had to support the Isle of Wight trials, the comparative trials. We came into the problem of having to produce multiple environments, so multiple instances of the system for test purposes, for development purposes, and start preparing staging and production to and do load testing and figure out how we're going to deal with X million clients and all of that. And having a 6 or 7 step list of commands for deployment very quickly became painful. So it was the trade-off was, do we introduce the Ruby with the given integrations that we already have? If you go online, there's a lot of there are a couple of Zulke modules, Gaudi modules, which are pulled out and they're open source now with the NHSX code. But it's pre-existing code, and the model and the way of working and the approach is battle tested, have been used again and again.
Did you share any of that with MIT's work? Probably
yeah.
Nice. Interesting.
And this is the point where these little usable pieces of code. So if you organize that build system code in a team and it's easily reusable, and this is something I do very often nowadays, it can be added into a system like this. So any Gaudi module residing in a lib subdirectory in a repository can be added to the current repository like this with this command. Now, Gaudi started life as a C++ build system, very opinionated, its own structures and all of that. And over the years, the parts that I just showed are the parts that that added value in projects using stuff other than C and C++. And but that opinionated way of building C code still exists as a Gaudi module, as a set of helpers, and that is actually the most complex Gaudi module that exists, C++ being what it is, and it can be added into any system with this type of call. And what it then becomes is that code is copied locally, it's added like this, and all I have to do is go to the system configuration and add it. I'm not going to add it now because we don't have any C code. And so, and yeah, this is a quick and easy way. Now there is a point, there is a clarification in the documentation and the code. The decision to not make Gaudi a library and not make it a package that can be downloaded by a package manager, and not make the helpers gems so they can be downloaded with Kanama is a conscious decision. Originally, in the very beginning, I did exactly this, made it into packages, but then it gets very complicated trying to release build system functionality via packages, and you get a lot of inconsistencies. So the choice is to actually copy the code into the repository residing right next to the code you actually want to build and automate, so that any changes are immediately in effect. And that's the point. That's why this whole concept eschews package managers.
So what you're saying is, if I get you, there's a bit of a delay and some husbandry issues associated with packaging anything up and going back to raw source and compiling afresh.
It's not only that, it's a matter of provisioning. Do my CI agents have exactly the same version of packages that I am using locally? If I package my build system as packages, I need to version them, and I need to ensure before I run any build process that the agent I'm running the build process on actually has the version I want to run it on. I solve all of this problem in the simplest possible way: clone the repository.
Thank you.
The idea is that the revision you're cloning should be consistent for everything you want to do in that repository.
Brilliant.
Now, yeah, and this is, I've shown everything I had to show. I think it's sped through it, but we are quite okay. The repository, the Gaudi example repository actually has a little bit more elaborate code in building this Docker image, development environment image. This is now the point where, for me, it becomes hard differentiating what is. It's not Gaudi, it's Docker. It's manipulating Docker and figuring out how to do smart things in the Docker ecosystem, like calculating shares of the Docker file contents and the Docker images context so that it can be tagged with specific versions that match the revision that is committed to the repository, and making a little adjustments so that the build system does not blindly and naively always download gigabytes of data, but figures out if it exists locally or not. So things like that. But these refinements become possible because all the user is going to do is build devend or pull devend something like that. So that the first implementation is always, let's just build the thing. And then once we keep using, we figure out as a team how we optimize our own processes. The process, the actual process does not change, but the implementation of what it does change. We can refine it, make it better, make it faster, make it introduce caches and all of that. It can get a lot of very, very complex if we want. And like I said before, the largest open source repository for Gaudi code is the NHS COVID-19 backend code, and that is, the link is in that slide.
That's it. Great. Vassilis, I found that I didn't really understand what was going on here until I had to use it myself. And I think getting started, there's a bit of a hurdle. People have, I mean, there's this example of things like this, which are great to work through. But if I want to try to use it on a real project, what sources of support would I be able to draw on?
There is, I mean, there's the repository where the core is maintained. That has more. Where's my repository? So, which is oh, come on. This. So this contains the ideas behind it, the motivation, and the way, the technical ways of how to extend the system, how to add to the configuration, how to build it together. The example, what I showed today, is actually pretty new because I did it for today's workshop. Is a very step-by-step start. This is the first meeting, and then there is a gap, and then there is the NHS COVID-19 backend code. So in between, yeah, there's me and a couple of other people.
Wow.
Well, obviously, I'm around. If anybody really wants to use it, I'll be happy to advise. I may have to refer to you as well.
One of the things that I realized while we were doing this, because it had to be handed over and taught and introduced, it actually got, while we were building the backend, it got introduced into other teams and other systems within the COVID-19 system of systems, so to speak. The actual hurdle in the beginning was knowledge of Ruby, and there is a very small set of the language that needs to be taught in order for people to be able to read and develop this. It's you can run away with the language and do very, very fancy stuff. And I've actually had one of the experiences that we had intern within Toolkit was exactly this. One of the engineers fell in love with the capabilities of the language and produced a system that nobody else could understand. And it was a built system. So this is what, out of that experience came the build system code needs to be naive. It needs to be understood by people that don't want to deal with the build system. So it needs to be read from top to bottom, be very explicit with what it does, and choose the naming of the methods and what they do should be very descriptive, easily understandable. The code should read like a paragraph.
And Vassilis, if you were to teach that subset of Ruby to someone like me who doesn't know Ruby, roughly how long would you need?
I have 4 hours. I did it in 4 hours, like really at more or less this speed in this style, just like I did this for the team, for the NHS team, and it's exactly 4 hours.
So basically,
it's 4 hourly casts, webcasts. So to speak.
A morning or an afternoon or a split session on our SPA conference. That would be good.
There are brilliant online tutorials as well.
Yeah.
which teach
Yeah,
you-
I mean, the Ruby, learning Ruby is, there is a lot of material in there, and the language is really well supported. And there's a lot of material for learning it, and yeah, it can be done. Like I said, I made it I'm very explicitly pulled out exactly the parts of the language that are relevant to building a build system. So the Rake DSL, how to introduce packages, how to manage gems, and the 4 or 5 object-oriented concepts that Ruby implements and how they're implemented to be able to read the code. And that's 4 hourly sessions. That's
Wow.
how we did it.
Yeah. And of course, it's the only language about which the Kaiser Chiefs have ever sung a song.
Ruby Tuesday.
Oh God.
It's the thing about this. Like I said, it was a very it was a difficult decision introducing the system into the NHS software thing that we had at that point in time, mostly because the team was had no contact with the language. The language was a barrier, and it's so we had a lot of we had to actually solve this problem. How hard is it to actually have a set of engineers who are not familiar with the ecosystem, with the language, with the syntax? How much impact does that have in what we do? And the solution to that was to actually pick 1 or 2 from the team to shadow the people who knew the language and the Ruby and introduce this in the beginning. And the rest was solved by the consistent user interface, because it's command line. It says rake and then task, rake and then task. And what the thing that I loved there is the resulting documentation. So when we had to actually support this system in production, and we had things to do, and we had to write how to do things, most of that documentation is like a paragraph and single task invocations.
Yeah, I can also explain what happened. We had a number of separate teams, and the team I'm working on is called the platform team. To begin with, we thought that platform operations was going to be quite low level, and so we just scripted stuff in Bash. And as time went on, after 3 or 4 months, we realized that Bash scripts were becoming extremely complex, difficult to debug. There's no consistency, no self-documentation. You have to keep diving into the script to find out what it does. And so there was actually pressure from within our team to switch over to the Rake system using Gaudi. And actually, the conversion wasn't that difficult, because initially we just implemented each of the tasks as calling the existing Bash script, and then just replaced it.
Over.
Yeah.
So you can prototype on it as well.
Oh, yeah.
Very easily. And if somebody goes into the NHS system now, they will get overwhelmed. It's a huge thing, and everything is in there. Everything is a task. Everything we do in that system is a task. And it takes us about a month to introduce a new engineer to every corner of it. Yeah. But we build it step by step, and the consistency in the structure that the structure introduces and where the things go, and the extra stuff is like documentation goes in doc, production goes under source. All of the build system is under tools built lib. You want the tasks, the namespaces of the tasks correspond to what we do. So deploy, test, package, release.
You said that was your biggest challenge, namespace. So how did you overcome that?
Okay, this is the other aspect. This is like Gaudi is the sweet spot for keeping the code clean, concise, readable, and leveraging an ecosystem that is mature and gives you a lot of capabilities like AWS SDKs, Azure SDKs, and all of that. This code exists in Ruby and libraries, and so it's that's why this combo is introduced. The rest, the naming, the namespace in the organization, this is build engineering, and we start with structure. And one of the initial problems that we talk about is how do we map our architecture and our domain onto the repository, onto the directory structures. And this is where, in my experience, usually when people are called to solve a problem, they go and map first using the domain. So I'm going to build app A. So the first directory they put down is app A. And then, okay, there is documentation for app A and the source of the app A and the thingy, whatever, and all of that. This is might look intuitive in the beginning, but it is the wrong problem. They are putting the domain of the solution domain first, so they're mapping it first, and then they go and start putting the software development domain aspects. What is documentation? What is test? What is source? What are tooling? All of that on the second level. Now, if we reverse this, because what we want to do is we want to do software development, so that the structure reflects the domain. If we reverse this and we do, here's where documentation goes, here's where the source, these are the tools, that's where the tests go, we don't have confusion when there is something like an integration test that cuts across two systems or two applications in our system. Hey, there is no question, where do I put this? So that's what the structure aims to achieve. So we're going like, this is documentation. And then we start, the second level is that in the NHS system, in the backend system, it's actually obvious. It maps to the architecture. So if one takes the high level abstract architecture diagram where the system of systems is graphed, and then take the big boxes, those will be the second level of directories in the sources. And then zooming into the architecture, we map this as close as possible to that end. And this becomes what I always want to achieve is avoid exceptions. There should be patterns and rules of where things belong and how things are named, so that I don't have to keep a list of exceptions in my head for where things are. This context, this is cognitive load of figuring out. So I have a set of rules, and this set of rules is reflected in the directory structure, but also in the namespaces of the build system. And what I have found as a build engineer, when I used to do this, is that it helps naming tasks the way the team talks about doing things. So if they have nicknames for the computers and go like, I'm going to go deploy Mike. Okay? The task is deploy Mike, because that's how we talk. Now it gets a bit more abstract and more philosophical. Basically, we are building a project-specific language when we're building the build system.
Super.
I think maybe at this point, if there are further questions, we can give another 5 minutes or so, but we should be wrapping up gradually.
Well, I'm just interested if there is a front end and a back end.
Is there a front end and a back end, Vassilis?
For what? For Gaudi? No.
Yeah.
It's all command line.
It's basically all front end.
What I have found over the years is that you can build anything with it. I mean, we've done iOS apps, we've done Android apps, we've done cloud-based serverless, we've done C, C++, close to the metal embedded. The abstraction layer is the added value.
Terraform.
Yeah, I mean, we use it a lot for Terraform.
I was going to say that Terraform, so basically it's still the same. It's your universal room of requirements, Harry Potter land.
What we do here is we actually nail down how we use the tools. And that's it. We codify our usage of the tools, and we ensure that everybody uses it the way we think they should be used.
It's more like
And
a
that's
uniform way of doing stuff. So you can make sure that we're all on the same bandwidth, so to speak. Everyone codes the same way, documents the same way in their domain specific area.
Yeah, that's been my experience, particularly on the NHS project, which was staffed by people from literally all over the globe who hadn't worked together before, and yet found it very easy to actually collaborate on this because everybody knew what the conventions were. And that was kind of just given to you by the tools, and so you didn't have to think about it.
Again, our background, Zulke as a technology consulting company, we have a lot of teams that make a lot of projects. That attribute, so the known conventions and this structure you don't have to think about is enormous help for cycling engineers in and out of teams, for finding your feet quickly, onboarding somebody in a new project and all of that. But it's a different use case and a context.
Cool.
Okay, I think we can wrap it up there. Thanks very, very much for your time, Vassilis.
Oh, thank you very much. I enjoyed this.
Great.
It gave me also a chance to, distill a few of these things.
In 4 weeks' time,
in writing.
we've got right back to basics. A lot of people they use the internet, but they don't necessarily know how it works at the bits and bytes level, how VPCs and subnets and things like that work. So a lady from Glasgow has kindly volunteered to give us a grounding in that. So this is very much at the beginner's level. If you want to find out about interneting, about networking, please come along in a month's time. And thanks for listening.
When you're in London, we'll take you to the pub.
Yeah.
I'd love to go to the pub now. Have a nice evening, everyone.
Thank you, Vassilis.
Thank you.
Thank you.
Thank you, Vassilis. Thank you.
Thank you. Dziękuję.
Thanks.
Hi, Tom.
Hi, everybody from Norway with snow on the ground.
Did you find that very agile?